Okay, we did the normal distribution yesterday. I'm going to start with an example of what we did yesterday that I skipped, so thanks. You don't have this example? Actually, this isn't the one I want to do even. Okay, remember we got to the z-score business? Okay, and then we used the normal CDF on the calculator. Give me a second. I'll find a good example here. I lied. Okay, we're going to talk about this one. The average number of points that a basketball team scored during a single season was 63 with a mean of 18. Okay, if this is 63, I just said that totally wrong. The mean is 63. The standard deviation is 18. If we add 18 this way, we get 81. If we subtract 18 this way, 45. How'd I do? If there were 15 games during the season and the percent of games in which the team scored more than 70 points. Okay. Do you remember what percent was in here yesterday? 34%, right? But is 70 on one of those magical standard deviation lines? No. We want to know everybody who scored above a 70. We did it two ways yesterday. We learned that we really could let our calculator do all the work. But the first time we did it, we used a z-score. We said that a z-score was the difference between a value in the mean divided by the standard deviation. So if we want 70 and the mean is 63 and the standard deviation is 18, what do we get? (7/18) or anybody helping me? 0.38. Okay. Then we used the area under the curve or the normal distribution. We went to normal CDF and we said we want from 70 on up. Oops, no. Oh yeah, that says 70. Okay. Upper limit needs to be at least 4 standard deviations above. So we could take 4 times 18 is 72 and add that to the mean of 63 and get like 135 if I did that right in my head. It's probably wrong. But we also talked about that if you just want all the way up, you could put like 999 or something there, right? Oh, wait, I wasn't going to do that this way this time. I was going to use the z-score. Don't hurt me. Using the z-score, help me out here. What was our lower limit? 0.38? Okay, sorry. I want to do it first with the z-score. 0.38. Do you remember what the top standard deviation was? They said go out how many? I just said it. Go out 4. So if we do that, 0.38 to 4, we get 0.35. Yesterday we did also do it without finding a z-score at all, and that would be where we put 70 to 999 with a mean of, what was it guys, 63 and a standard deviation of 18. Okay, so close, right? And we could have put in a longer decimal for our z-score and got even closer. All right, but around 35% of the team scored more than 70 points. All right, I just wanted to do an example and review what we did yesterday as a warm-up, because today we're going to say, what if I want to know how to score in such and such a percentile? Okay, so I know the percentile and I want to find the score. In other words, if I know the mean and standard deviation for the ACT, and I know I can get a scholarship if I'm in the top 90%, I can work backwards and figure out what score I need to get in that 90th percentile. All right? The key to do that is going to be right below the normal distribution on your calculator. It says inverse normal. Does that kind of make sense? We're doing the inverse, okay? Let me talk through this, though, with you. The first thing it talks about is z-scores. If you want the middle 20% of the data, listen closely here, you have to say, well, I'm at the 50th percentile. If I want the middle 20, I'm going, divide that by 2, and you're going 10 each way. 10% this way and 10% this way to get the middle 20, which means you want from 40 to 60th percentiles. Does that make sense?
Yeah.
Okay. So this is what they did here. They did the middle 50%. Normally, if we went out one standard deviation each way, we'd be at what percent? 68. Everybody remember from yesterday, empirical rule? Okay. If we go out only 50% total, so what percentile is this at? This was the halfway. We want to go 25 each way because we want the middle 50th. So 25% each way. So 50% minus 25 is 25. 50% plus 25 is 75%. All right, this will give us the z value, z-score. If we go to second vars and down to inverse, the lowest 25% would be the area under the curve at 0.25. So we're just going to put 0.25, leave this 0 and 1, and we get negative 0.67. If you do this for the top, which was 75%, whoa, I picked the wrong thing. So if we put it at the 75th percentile, miraculously, we get the same value, but what? Positive. Do you remember? I can even show you the slide from yesterday where it showed when you do the z-scores, it's symmetric. Remember, we go -1, -2, -3, +1, +2, +3. So our 50 percentile was in here from -0.67 to +0.67. Make sense? Okay, going back to our slide, let me find it. You would write this by saying the z value has to be between here and here. Does that seem okay? All right, this, it's symmetric. That's why positive, negative. Outside, need you to pay attention here. If you want outside 20%, that's the total on the extremes. So you still have to divide it by 2 and say I want 10% at the bottom and 10% at the top. Luckily, that's 0.1, 10% here, and 1 back from 1, 10% would be 0.9. Okay? You put it in the calculator. 0.1 gives you -1.8, and this 10% can be below that. Positive 0.9 gives you a positive 1.28, so you could also be above that many standard deviations. And those two areas together would make the outside 20%. All right, talk me through this real fast, just because students struggle with this. I don't know why, but if you want the middle 25%, what are the two cutoffs? If this is the middle, and you want a total of 25% in here, you have to go down how far and up how far? Okay, everybody good with that? You have to go half each way. So 50 minus 12.5 is 37.5. And up this way it'd be, okay. And when you were done, your z-score would be sandwiched in between those two values because you want the middle 25%. Anybody do a z-score yet for either one of those? They should be one positive and one negative. Inverse norm, 0.375. 3. Okay. What about this one? If you want the outside 60%, divide it by 2, and you want 30% on either end. So the bottom 30% is just at 0.3. What is the top 30%? Everybody good? 100%? Back up 30%? You're at 0.7? Good. Anybody do that one? Inverse norm. This one, when you write it, you have to say less than or greater than, because you're looking at these percents out here. Or above 0.52. All right, here's the ones you have on your paper. Middle 60%. How much is that either way off the middle? Divide it by 2, and we need to go 30% off the middle. This way would be 20%, and this way 30 would be. So when we go to put it in our calculator, we're going to do inverse norm of 0.2 and 0.8, which should just be opposites of each other. And are we going to write a sandwich sentence, or are we going to have some below and some above? Okay, so that sandwich sentence will say Z is going to fall between, anybody do it? I'm hearing different things. 0.8 something? Faisal, is that what you got? You're okay? No birthday cookies for you. Huh? Did you get it now, Faisal? Okay. Outside 30%. Be careful. That means some at the top and some at the bottom. What percent? Okay. 0.15 down here, or 15%. And the top 15%, which would be 0.85. And when I go to write it, I need to say Z could fall below, not X, Z, could fall below what score? Negative. Or above positive 1.04. Is everybody okay? All right. Well, this is cool. We learned yesterday that just using the straight up data is easier than even doing the z-scores, right? So on one of these, we're going to figure out how to do this just a little bit differently. On those questions we just did, they didn't give us a mean or standard deviation, right? So we just had to find the z-score that would give us that percentile. This says the prices of rooms, I'm going to move this down a little bit. The prices of rooms at hotels around an airport in this city are normally distributed with a mean of 120 and a standard deviation of 20. I like this one because it doesn't hurt my head. 180, 60, 140, 160, 180. Did I add and subtract 20 correctly, guys? Okay, and we could go out one more standard deviation, but I went out 3 each way. What percent does that encompass? 99.7. Very good. Okay. This says, what is the chance that the probability that the cost of the room is greater than $150? Okay. Is that on a standard deviation line? No. We need all of it above 150. Do you remember how we did this yesterday? We didn't use a z-score. Do you remember that? We eventually just went to, is it called norm CDF or is it normal CDF? I can't remember anymore. Okay. What did we put in first? The cutoff at the bottom end, which would be what? 150, because it says 150 and up. You can go out 4 standard deviations, so we could go out to 200, and we could put 200 down, and that'd be fine. Or you could put like what? 1 million. You could put 999. You could put whatever you want, okay? positive. Okay? It's got to be at least 4 standard deviations above 120, which would be 200. You can put something bigger. You get a slightly different answer, but it's fine. No, it's so many decimal places out that it changes, it won't even matter. Then what? Next thing it asks for is the mean and the standard deviation. If you have an older calculator, can anybody tell me what those cues were that it gave us that the old one doesn't? It says low, high, mean, and standard deviation. Okay? Anybody get an answer? Oh, yeah, we're asking for percent. You're absolutely right. I was thinking we were asking for money. It's like 6.7. All right, you guys are perfect. I've only done this question 3 times today, and I still can't remember what we're doing. All right, 6.7% of the rooms would cost more than $150. Okay, did I finally make it make some sense? Now, it says between 110 and 130. This means right around in here. What would we get? What percent? That's even easier, right? We don't have to think about the top. They gave us both the bottom and the top. 110 to 130, 120, 20. Anybody in agreement with Benji? 38.3? Yeah, that's not looking very readable. All right, between 90 and 100. Look up here at my graph just so you can think about what kind of a number this should be. How much area is going to be between 90 and 100? Not very much, right? Okay. All right, what'd you get? 9.2%. Oops, 100, right? All right. What if they give us the percent? If only the most expensive 10% of the rooms are available, what is the least you will pay for a room? There's 2 ways we could do this. We could find the z-score and then use our formula for a z-score to go backwards. Okay? We said 10%, but it's the top 10%, so we'd want what? 0.9. Inverse norm 0.9. That'll give us the z-score. But if you look at that inverse norm screen, is there something else we could put in for this question instead of just finding the z-score? What if we don't put in 0 and 1? We put in a mean of 120 and a standard deviation of 20. It'll spit out exactly what that cutoff cost is. I'm just going to leave it at $145. So what is the least you will pay for a room? You will pay over $145. Everybody okay? All right, this one says students who score in the bottom 5% of a physical education test will be enrolled in a supplemental PE program. I have to have PE 7 hours a day, okay? Some of you would like that. The scores of all the students who took the test are normally distributed with a mean of this and this. Was this a 100-point test? Not if the average was 122.6, right? Okay. What is the greatest score that a student who is enrolled in this program could receive? So if I drew this, I'd have 122.6, 18 either way, blah, blah, blah. But what percent do I care about? Just the cutoff at the bottom 5%. What percentile is that? 0.05, right? It's not, if it's the top 5%, we'd be at 95%, but it's the bottom, so it's just 0.05. We're given a percent, and we're going backwards. So we're going to do inverse norm, 0.05, where the mean is 122.6, and the standard deviation is 18. So is it a percent?
No.
Cutoff score of Philip. It could have been a no. That's what I'm saying. That's the mean score. So we don't know what the percent. That's the 50th percentile.
Because like I thought
okay.
The answer bottom 5% would be that'd be the last or the first 5% of the.
But it's not a 100-point test. That's what I'm saying. Yes, it would be the first 5%. If the mean score was 122.6, the average score was 122.6, the top score was like 4 standard deviations above that, which would be 4 times 18 or 72 above that. So maybe it's a 200-point test. I don't know. Okay? It's a physical fitness test, so I don't know how many points it was out of. But that was what I wanted you to get out of that, with it's not a 100-point test. All right. Yes.
Why did we find the smallest and ask for the greatest?
What is the greatest score? Because it says the bottom 5% are going to get enrolled in this. So everybody with a score below 93 is in that bottom 5%.
Oh.
It is confusing, but it wants the top score that will put you in the bottom 5%.
The first place loser.
Yes. There you go. All right. Guys, this one says that we're going to do a medical research study of some kind, and we've got a bunch of people whose average weight is 190 pounds. Okay? The mean is 190 pounds. The standard deviation is 12. It says if the main focus is those whose weight are in the middle 80%, okay, I need to know how to find the middle 80%, the weight cutoffs for the middle 80%. If I divide that by 2, I'm going to go how far each way? 40% from the middle would put me at the 10th percentile, right? 40% above the average would put me at the 90th percentile. The z-scores for those would be opposites, but if we want to be lazy and just let the calculator do all the work, we're just going to have to do it twice. We're going to do an inverse norm of what? 0.1, comma 190/12, and then the same thing with 0.9, 190/12. Anybody figure out where our range is?
0.1 is 174.6. And 0.9 is 205.4.
So the range of weights included for the focus of this study is the people who weighed between 174 and 205 pounds. Okay? It says if participants whose weights fall in the outside 5% are contacted 2 weeks after the study. So 2 weeks after, we're worried about those people at the very ends. We're going to call them 2 weeks after the study. What's the cutoff weights for those? 5% outside, though. What does that mean? We got to divide by 2, so it's the bottom and the top, what? Okay, so what am I putting in my calculator? Inverse norm, because that clearly is a scribbly mess. 0.025, comma 190, comma 12. That'll give me the bottom cutoff. Anybody?
97.5.
So everybody who weighs below 166, we're going to call and check on them. And then the top 2.5%, be careful. 100 minus 2.5 is 97.5. So we're going to use 0.975, comma 190, comma 12. And get what? $215? 213? 213, 214, somewhere in there. Are we good? Okay. Last little tiny piece. We talked about this yesterday. Z-scores can be used to compare two completely unrelated pieces of data. So for example, the z-score tells you how many standard deviations above or below the mean. Somebody took a bio test. What did they get? It says they got a 65, where there was a mean of 50 and a standard deviation of, so how many standard deviations above or below the mean did this person score? Okay, so on bio, she got a 1.5 standard deviations above the mean. What about lit? On her lit test, she got a 30 out of 25, where the mean was 25 and the standard deviation was 5. So what'd she get there? Only one standard deviation above. So which comparatively did she do better on? Okay, she scored further above the mean score on the bio test. All right, have a question like that on your homework. Easy peasy. Okay, this is the bookwork on this section. I can put that up on the screen if you want me to. But you have the rest of the period to work on all the stuff that's due on Tuesday's homework check.